Is my voice audible? All right. So yesterday we have been doing questions from 1 on to many one into. And we did this one linear upon linear question. Then this question out of which three statements are given and only one was correct. Then this cubic polynomial with roots as 1, 2, 3. Then this cubic polynomial plus a trigonometric polynomial function. Right? This is what we call transcendental functions. About this, then some more examples. So I hope you got some better idea about 1, many one, onto and into functions. Am I correct? Am I correct? All right. So now let's start with composite functions. Composite functions. This is what we call function of function. Got it? So, first of all, we will do composite function of uniformly defined function. Uniformly stands for defined by only one rule. Defined by only one rule. Am I correct? So, just first of all, for a basic idea, let there is a function f defined from a to b, that is fx is x square plus 1. And there is a function g defined from b to c, that is gx is equals to 2x. Got it? So what is happening? Say this is set A, set B. Now A to B function f is defined. Then this is set C. Then B to C function G is defined. Now what is happening? Say first of all, there is an element 1. In 1, what f1 will give you? In f1, that will be 2. Now you are supplying this value 2 to G function. And in that function, what do you get? You get G2. And G2 will be 4. Am I correct? Now say there is an element 2. First of all, you get F2. F2 will be 5. Now this 5 goes to G. You get G2. Sorry, G5. G5. And G5 is 5 to the 10. Then say there is an element 3. With this 3, first of all, you get F3. F3 will be what? 3 squared, 9 plus 1, 10. Then this 10 will go to G. Then you get G10. G10 will be 20. And so on and so forth. This is how it is going. Now this composition is what we call this composition that you see here. This is what we call GOF. Am I clear? So GOF is defined from what? From A to C. GOF is defined from A to C. And what do we call GOF? GOF is what we call G of fx. Function of function. Got it? GOF is what? G of fx for every x which belongs to A. So that is what happening. If I ask you for golf of 1, what it will be? Finally 4. If I ask you golf of 2, what it will be? Finally 10. If I ask you golf of 3, 20, and so on and so forth, there will be more elements. Now, exactly what is golf? Golf is what? G of fx. Now, fx is what? Fx is x square plus 1. That is g of x square plus 1. Now, your gx was 2x. If you want to find g of x square plus 1, that means replace x by x square plus 1. So, what do you get? Twice of x square plus 1. Have a look. Understood? Now, let's do a question. Let's do a question. Got it? Write down a question. Say fx is x minus 1 upon x plus 1 and gx is x square. Find FOG, GOF, FOF, GOG, and hence find their respective domain and range. Yes. Give it a try quickly. Quickly try. चल Yes, anybody? Now see. If I talk about FOG, FOG will be f of gx. Gx is x square, so it is f of x square. So it will be x square minus 1 upon x square plus 1. Understood? Now domain will be what? X belongs to R. For the range, let us assume y is x square minus 1 upon x square plus 1 cross multiply. So y is x square plus y is x square minus 1. So that is x square into y minus 1 is minus of y plus 1. Am I correct? So x square is going to be minus of y plus 1 upon y minus 1. Now since x square is more than equal to 0, this also should be more than equal to 0. Means y plus 1 upon y minus 1 should be less than equal to 0. And from there you get y lying between minus 1 to 1. 1 not including because it is in the denominator. Understood first question? So domain you got, range you got. Clear? Now let's do with GOF. GOF is g of fx. That is g of x minus 1 upon x plus 1. Unknown caller. That is x minus 1 upon x plus 1 whole square. Simple. What should be domain? Domain should be x belongs to R minus minus. Now for the range, let us assume y equals to x minus 1 upon x plus 1 whole square. Got it? So let us do one thing. First of all, I will find the range of this inside quantity. Then I will do the square of that. Got it? Let us assume P is x minus 1 upon x plus 1. So from this you can say that is Px plus P is x minus 1. So it is x times P minus 1 is minus of P plus 1. Got it? So x is what? Minus of P plus 1 upon P minus 1. That means P belongs to R minus 1. P is everything except 1. Now if you square that, so P square will belong to what? P square will belong to 0 to infinite. So that is your y. So GOF, that is x minus 1 upon x plus 1 whole square, its range will be inclusive of 0 to infinite. Now you must be thinking one is not part of the domain. How can one is not part of the range of P? How can it be a part of range of P square? But if you realize minus 1 is part of range of P. And when I square that, it will be minus 1 square, that is 1. So 1 will also be a part of range. Now we will do FOF. FOF. That is f of fx. That is f of x minus 1 upon x plus 1. So it will be now in fx, put x minus 1 upon x plus 1 instead of x. Minus 1 upon x minus 1 upon x plus 1 plus 1. Am I correct? So it is x minus 1 minus x minus 1, x minus 1 plus x plus 1. So this comes out to be minus 2 upon 2x. That is minus 1 by x. This is your FOF. Got it? Simple question. Now, as far the domain is concerned, x belongs to R minus 0. Similarly, range, if you talk about, y also belongs to R minus 0. Fine. Now, if I talk about GOG, that is G of GX. That is G of x square. That is x square square. That is x to the power 4. This is your GOG. So domain is what? X belongs to R. And range is y belongs to, since it is x to the power 4, always positive. So it is 0 to infinite. Am I clear? So this is how we deal with domain and range. Done? Anybody? Is there anyone who would like to ask something? Got it? No. Am I clear?
Hello. Hello.
Hello, students. I'm sorry for the inconvenience. This we just have some technical issue. So, teacher can't able. Hello. Hello. The students, today class was cancelled because of teacher have some technical issue. So we'll see tomorrow. Thank you.